The next transformation that we're going to talk about is stretching. So there are two types of stretching, and they are obviously vertical stretch and a horizontal stretch. The first one that I'm going to be talking about is a vertical stretch. So if we're stretching something vertically, what that means is we're really just stretching the y values, but while keeping the x values intact. So let's say for example I have, once again, just sort of an xy plot, and I just keep a random point. Let's stick with the 2, 3 that I've sort of been using before. So let's say that's 2, 3. And so in other words, here's 2 and here's 3, right? If I were to stretch this point, just simply this point in the y direction while keeping the x intact, what would happen is that this 3 would then double. So in other words, it would double to 6. So this output would become 6, but the input would still remain 2. So in other words, this coordinate right here would be 2, 6. So once again, what this does, let me just put green. So vertical stretch affects the output, which is the y, while keeping the input, which is the x's, intact, right? As we can see over here, when we stretch it this way, it goes from 3 to 6, but the x's, or in other words, the inputs, remain the same. So it's 2 and 2. So how do we write this? How do we use the functional notation? Well, let's say, for example, throughout this, let's just say I have a variable a, and I say it's an element of real. So let's just say it's a real number. Or actually, let me say it's a positive number. So in other words, a is just a positive real number. So say, for example, I write y equals a f of x, right? So what this means is, if you observe over here, the x's are not touched. There's nothing affecting the x's. So the x's remain intact. While the outputs, if you observe, they're being multiplied. So it's being multiplied. The y's are now being multiplied by a factor of a, right? So say, for example, let's say I said y equals 2 f of x, right? The x's are not affected at all, but now all the y's are being multiplied by a factor of 2. So for example, in this case, we would say it's a vertical stretch, or actually, hold on, a better way to say it is a stretch in the y direction, because obviously we're just simply affecting the y's. I-O-N, excuse my, I don't have space. So a stretch in the y direction by a factor of 2. So let me just scroll back up a little bit. So as you can see, that 2 is just stretching in the y direction. So it's a stretch in the y direction by a factor of 2. So let's show this with an example. So once again, here is my f of x, and here are the edge points, which are once again 1, 2, 2, 4, and 4, 1. So let's say, for example, now that I go from my original function, which is y equals f of x, and I'm making a transformation by saying y equals 2 f of x. What will this new function look like? So once again, as before, remember, always write what the transformation is in words. So here we'll say this is a stretch. This is clearly a stretch in the y direction, right? Since it's affecting the y's by a factor. In other words, a multiplication factor of 2. It's very important that you say by a factor. So what that means is, so this is the old xy table for this original function. What will the new function look like? Well, as we said, the x's remain the same, so that remains the same. But all the y's are stretched by a factor of 2, so in other words, they're doubled, so it's 2y. So what would that look like here? It would be 1, 2, and 4. And the y's would now become 4, 8, and 2. All I did was I just multiplied each of these by 2. So that's what we get. So let's plot this. So for example, our first coordinate is 1, 4. So 1, 4 would be somewhere here. Then we have 2, 8. So 2, 8 would be somewhere here. And then 4, 2 would be somewhere over here. And let me just connect these dots with a straight line. So we can see that's over there and that's over there. And we can clearly see that this function, oh, actually, hold on, before I do that, let me just write what this new function is. So this is 2 f of x, right? So the yellow one, let me just move this over here. The yellow one is this one right here, and 2f of x is right here. And clearly we can see that this original function has been stretched by a factor of 2, and it really looks like that. All right, in the next video, I will go over the next type of stretch, which is a horizontal stretch. See you in the next video.